Good afternoon, all of you. Today we are going to start a new topic, that is refraction of light. So, in this topic, refraction of light, we are going to discuss what exactly is refraction. Now, you know that light can pass through transparent mediums. Okay. The condition for passage of light is that the medium has to be transparent. So light is passing through one transparent medium and there is a boundary, and on the other side there is another transparent medium. So there are two transparent mediums, one is here, and this is the boundary between them. And AB is the light which is falling on the boundary, and BC is the light which is going through to the other side, that means to the other medium. Now what happens is, you will notice that the direction of AB and the direction of BC is not the same. The direction of AB is this, but the direction of BC is something totally different. So, or you might say that this is the direction of AB, like if you produce this AV line, dot 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 dot, so this would have been the direction of AV. But now you have placed another medium. So thanks to this other medium, instead of following the path AV, it is bending and following a different path. Now why does this happen? Actually, you must have heard of this famous sentence, speed of light is 3 into 10 to the power 8 meter per second. It's very well known. So speed of light so speed of light is 3 into 10 to the power 8 meter per second, but in vacuum. Okay, so this is a very famous sentence that we keep hearing, speed of light. So speed of light is 3 into 10 to the power 8 meter per second, but that is in vacuum. Now, the thing is that when you consider any other medium other than vacuum, then the speed of light is less. So if you consider any other medium other than vacuum, then the speed of light will be something less. It will not be 3 to 10 to the power 8 meter per second, it will be something less. So what is happening is, suppose let us say AB is the light which is going through vacuum and BC is going through some other medium, right? So vacuum means the speed will be 3 to 10 to the power 8 meter per second, and BC will be some other medium, so it will be lesser than 3 to 10 to the power 8 meter per second. So the speed of light is 3 to 10 to the power 8 meter per second, and then it is decreasing to some other quantity when it is entering the other medium. It's decreasing and becoming some other quantity. So because the speed of light is decreasing, so what is happening is that since the speed of light is decreasing, so in the same amount of time it will travel a shorter distance. Now you all have heard of the famous sentence that perpendicular is the shortest distance. So this perpendicular is called the normal. Perpendicular means it is perpendicular to the boundary. This is called normal. This AB is called incident ray. Okay, AB is called incident ray. BC is called refracted ray. So this perpendicular is called normal, AB is the incident ray, BC is the refracted ray, and you can see that the incident ray direction is like this, and it is now bending towards the normal because the speed has reduced, so it is going to travel lesser distance, so it is going closer to the normal. So that fact, that the ray is going closer to the normal, it suggests that the speed is less here and the speed is more here. Acha, wherever the speed of light is less, it is called the rarer medium. I mean, wherever the speed of light is more, that is called the rarer medium. So this is the rarer medium, speed is more, and wherever the speed of light is less, that is called the denser medium. So here the speed is less, so it is denser. Here the speed is more, it is rarer. So rarer medium, denser medium. Okay. So once again, when light is traveling from one transparent medium to another, and in one of them the speed of light will be more, in another one the speed of light will be less. So the one where speed is more is called rarer, the one where speed is less is called denser. So the ray of light will change its path. So it was having a certain path. After going to the next medium, the path will change. The original path is incident ray, the final path is refracted ray. And the perpendicular common to the two surfaces is called the normal. Now the angle between the incident ray and the normal, this angle, this is called angle of incidence. and the angle between refracted ray and normal, this angle R, is called angle of refraction. So I is called angle of incidence and R is called angle of refraction. So when a ray of light is incident on the boundary of two mediums, then it refracts. Okay, refracts means it changes its path. It either goes towards the normal or away from the normal, depending on is it going from rarer to denser or denser to rarer. And this phenomenon is called refraction. And why does it happen? Because the speed of light in rarer medium is more, the speed of light in denser medium is less. Angle between incident ray and normal is called angle of incidence. Angle between refracted ray and normal is called angle of refraction. Now, the fact that one medium has got more speed of light, that means it is denser, it is rarer. So that is also called by another term, optical density. So rarer medium means optical density is less. Okay. If I say that this is a rarer medium, that means optical density is less. And if I say this is a denser medium, that means optical density is more. So rarer medium, optical density is less, and denser medium, optical density is more. Right? Okay. And let us have two more diagrams. Suppose the ray is going from denser to rarer, then it will be like this. If it is going from denser to rarer, this is the incident ray, this is a refracted ray. So denser to rarer, this will be the diagram. If it is going from denser to rarer. And then you have something called normal incidence. Normal incidence means that the angle of incidence is 0 and angle of refraction is also 0. So it will go to the boundary along the normal, and without any refraction it will go through the other side without any kind of refraction. So that is called normal incidence. So these are the three situations. Rarer to denser, this is the diagram, bend towards the normal. Denser to rarer, bend away from the normal. Normal incidence, there won't be any refraction, it will just go straight through. Right? Okay, now all this is okay, but there has to be some mathematical correlation. It's true that speed of light is the mathematical correlation, it's true, but something better than that. So that something is called refractive index. So refractive index of medium 2 with respect to medium 1. So suppose I want to find refractive index of medium 2 with respect to medium 1. So you just say speed of light in medium 1 divided by speed of light in medium 2. So refractive index is considered to be the measure, right? So refractive index, I'll just write Ri. So refractive index of vacuum will be how much? 1. The refractive index of vacuum will be 1, because what is the definition of refractive index? Speed in medium 1 by speed in medium 2. So that means if you say refractive index of vacuum, that means medium 1, medium 2, like refractive index of vacuum is 1. Okay, now When I say refractive index, then it means speed in medium 1 by speed in medium 2. So there is another word called absolute refractive index. So absolute refractive index is speed in vacuum by speed in medium. So let me clarify again. If I say refractive index of medium 2 with respect to medium 1, it is speed in medium 1 by speed in medium 2. If I say absolute refractive index of any medium, it means speed in vacuum by speed in the medium. So for example, if I ask you what is refractive index of vacuum, so it will be speed in vacuum by speed in vacuum, that will be 1, like that. So that covers the topic basics of refractive index, and now I'll just give you some homework. Question number 1. Absolute refractive index of water is 4 by 3. So the question is, what is the speed of light in water? Question number 2. The absolute refractive index of water is 4 by 3. Absolute refractive index of glass is 3 by 2. So what is the refractive index of glass with respect to water? This is question number 2. Question number 3. The absolute refractive index of glass is 3 by 2. So what is the speed of light in glass? This is question number 3. Question number 4. Speed of light in diamond is 125,000 kilometers per second. What is the absolute refractive index? Question number 5. The refractive index of water with respect to air is 4/3. So what is the refractive index of air with respect to water? So these are the 5 homework questions. Question number 1. Absolute refractive index of water is 4/3. What is the speed of light in water? Question number 2. Absolute refractive index of water is 4/3. Absolute refractive index of glass is 3/2. So what is the refractive index of glass with respect to water? Question number 3. Absolute refractive index of glass is 3/2. What is the speed of light in glass? Question number 4. Speed of light in diamond is 125,000 kilometers per second. What is the absolute refractive index of diamond? Question number 5. Refractive index of water with respect to air is 4/3 and air with respect to water is how much? So these are the 5 homework questions of today's physics session. You must submit the homework before 9 p.m. tomorrow, 9 p.m. Tuesday. And if there is any clarification required in your homework, I'll ask you to join the meeting and clear it. And we will be having sessions like this at least 5 days a week. Okay. Thanks a lot. I'll end the session. Bye all of you.